Here's the problem formulated exactly as it shows up in various textbooks. And the formulation says the following. Well, consider one of those anachronistic places where they still have kings or queens and where actually boys take precedence over girls. So if there is a boy if the royal family has a boy, then he will become a king, even if he has an older sister who might be the queen. So there we have one of those royal families. That royal family had 2 children, and we know that there is a king. There is a king, which means that at least one of the 2 children was a boy. Otherwise, we wouldn't have a king. What's the probability that the king's sibling is female? Okay. Okay, I guess we need to make some assumptions about genetics. Let's assume that every child is a boy or girl with probability 1/2, and that different children are, what they are is independent from what the other children were. So every childbirth is basically a coin flip. Okay, so if you take that, you'll say, well, the king is a child, his sibling is another child, children are independent of each other, so the probability that the sibling is a girl is 1/2. That's the naive answer. Now let's try to do it formally. Let's set up a model of the experiment. The royal family had 2 children, as we're told, so there's 4 outcomes: boy, 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 girl, girl, boy, and girl, girl. Now, we are told that there is a king, which means what? This outcome here did not happen, is not possible. There are 3 outcomes that remain possible, so this is our conditional sample space, given that there is a king. What are the probabilities for the original model? Well, with the model that we assume that every child is a boy or a girl independently with probability 1/2, then the 4 outcomes would be equally likely, and they're like this. These are the original probabilities. But once we are told that this outcome did not happen because we have a king, then we are transported to this smaller sample space. In this sample space, what's the probability that the sibling is a girl? Well, the sibling is a girl in 2 out of the 3 outcomes. So the probability that the sibling is a girl is actually 2/3. So that's supposed to be the right answer, maybe a little counterintuitive. So you can play smart and say, oh, I understand such problems better than you. Here's a trick problem, and here's why the answer is 2/3. But actually, I'm not fully justified in saying that the answer is 2/3. I made lots of hidden assumptions when I put this model down, which I didn't yet state. So to reverse engineer this answer, let's actually think of what's a probability model for which this would have been the right answer. And here's the probability model. The royal family the royal parents decided to have exactly 2 children. They went and had them. It turned out that at least one was a boy and became a king. Under this scenario, that they decide to have exactly 2 children, then this is the big sample space. It turned out that one was a boy. That eliminates this outcome. And then this picture is correct, and this is the right answer. But there's hidden assumptions being there. How about if the royal family had followed the following strategy? We're going to have children until we get a boy, so that we get a king, and then we stop. Okay, given that they had 2 children, what's the probability that the sibling is a girl? It's 1. The reason that they had 2 children was because the first was a girl, so they had to have a second. So assumptions about reproductive practices actually need to come in, and they're going to affect the decisions. Or if it's one of those ancient kingdoms where a king would always make sure to strangle any of his brothers, then the probability that the sibling is a girl is actually 1 again, and so on. So it means that one needs to be careful when you start with loosely worded problems to make sure exactly what it means and what assumptions you're making.